Today's presentation will focus on tools that enable system administrators to create secure server environments. This presentation will discuss two tools in detail, AppArmor and the HTTPS protocol. We will begin with an overview of the AppArmor use case, followed by tips on how security professionals can optimize its effectiveness. AppArmor is a Linux tool designed to provide access control. Access control is a fundamental aspect of any strong security strategy, ensuring that only the appropriate individuals have access to data and applications. In most organizations, not all employees should have access to every file or piece of information. Allowing unnecessary access or failing to prevent malicious attempts to access sensitive information can expose an organization to both external and internal threats. However, ensuring that access is granted when needed and denied when it isn't can be a complex task. Tools like AppArmor can assist organizations in effectively managing this responsibility. AppArmor enables server administrators to create specific profiles for applications that dictate access permissions. In Ubuntu, AppArmor is pre-installed, and an optional package called AppArmor-utils is available, allowing administrators to modify profile modes, create new profiles, and enable or disable existing ones. There are two modes of operations for profiles: complain and enforce. The complaint mode permits access violations to occur while logging these incidents, making it useful for testing new profiles. On the other hand, switching a profile to enforce mode activates access control and logs any violations that may occur. For Linux servers, best practice recommends using AppArmor instead of traditional Unix access control. Unix relies on discretionary access control, which allows users to grant and revoke access to files and information. In contrast, AppArmor employs a centralized mandatory access control (MAC), enabling systems administrators to enforce access restrictions at the application level. Mandatory access control is generally considered more secure than discretionary access control. With Mac, access is more easily managed at the organizational level with clearly defined restrictions. This approach is particularly beneficial for companies that handle highly sensitive data, such as those in the banking and healthcare sectors, which must comply with additional regulations like PCI-DSS and HIPAA. For a mandatory access control tool like AppArmor to function effectively, organizations need to invest time in creating relevant profiles and user groups that categorize users based on the information they require access to. Examples of user groups may include employees, managers, executives, or individuals with different levels of security clearance, such as level 1, level 2, or level 3. These groups should be tailored to the specific needs of the organization. It is important that these profiles and user groups have clear definition based on a shared need for access. User groups that are too narrowly defined can lead to an administrative burden, while groups that are too broadly defined can compromise security. Like most security tools, AppArmor requires ongoing attention and management. When new profile and user groups are created, it is essential to test them to ensure that access is granted or denied as intended. When profiles are in force mode, logs will be generated and should be reviewed periodically to verify that the system is functioning as expected. Each time new applications or users are added to the system, it is also important to test and review the profiles and logs accordingly. We will now move to a similar review of HTTPS. HTTPS, which stands for Hypertext Transfer Protocol Secure, is a protocol used to encrypt data exchanged between a web browser and a website. It is essential for websites that handle sensitive information such as payment details, email correspondence, or healthcare records. To use HTTPS, as consumers, we can identify whether a website employs this protocol by looking at the URL bar in our browser. HTTPS websites typically display a padlocked icon to indicate that they are secure. The use of HTTPS helps protect data being transmitted online from being easily read. For instance, if an employee of an organization connects to a public Wi-Fi at a coffee shop, a malicious actor could intercept the information being sent. If this information is shared using HTTP, the unsecure version of HTTPS, it will be transmitted in plain text and easily readable. In contrast, if HTTPS encryption is used, the intercepted data will be indecipherable, appearing as a random jumble of letters and numbers. HTTPS encryption relies on an asymmetric public key infrastructure. This means that a website has both a private key and a public key. The private key is controlled by the website owner and it is used to decrypt information that has been encrypted with the public key. Public key, on the other hand, is accessible to all users of the website. This encryption protocol is known as Transport Layer Security, TLS, which was previously referred to as Secure Sockets Layer, SSL. Websites that implement HTTPS typically use port 443 as opposed to port 80, which is used by HTTP. Port 443 allows for encrypted data transmissions. Additionally, websites hosts provide their customers with a TLS SSL certificate. Each time a customer accesses the website, a TLS handshake occurs. This process establishes the TLS version, verifies the SSL certificate, creates session keys, and establishes an encrypted communication channel. Best practice for an organization's website is to use HTTPS. Historically, the transition to HTTPS was seen as a complicated process. However, advancements in HTTPS over time mean that it is no longer expensive to implement and does not significantly impact website performance. The use of HTTPS is now more critical than ever, as it signals to consumers that they can trust your businesses when interacting online. Today's popular browsers, such as Google Chrome, display the security status of website, and Google search results favor security websites. Consumers are unlikely to enter password or payments information on an insecure site. As organizations transition to cloud hosting, they typically obtain their private key from their vendor. However, keyless SSL enable organizations to retain control of their private key while still utilizing cloud-based services. Organizations can continue to use the TLS protocol, but can shift the initial TLS handshake to their own server instead of relying on a cloud vendor. This approach allows organizations to keep their private key secure and not share it outside of their own infrastructure. Communications between the vendor and the organization occurs within an authenticated and encrypted TLS tunnel. The Diffie-Hellman key exchange is an advancement in encryption security that offers improvements over the RSA, Reverse Shamir Admin handshake. While RSA is still the most commonly used encryption method, and it is considered very secure. The Diffie-Hellman handshake enhances security by utilizing ephemeral keys that are only used once. In this process, both the client and the server independently calculate private keys using agreed upon parameters to create session keys, resulting in a symmetric encryption structure. If these sessions keys are compromised, a hacker will only gain access to data shared during that particular session, as opposed to gaining access to all information shared through a compromised private key. This concept is known as forward secrecy. HTTPS is the secure protocol used for website, but it requires a web server to build and host the site. In the upcoming discussion, we will examine two options for web services, IIS and Apache. Internet Information Services, IIS, is a web service developed by Microsoft that operates on the Windows operating system. It facilitates the exchange of content between a server and a remote client over the internet. Organizations utilize IIS to host websites and web-based applications. IIS provides several key features, including website login for tracking usage and performance, web traffic filtering rules, and developer libraries that simplify web applications development. Many organizations choose IIS for its capability, and it can effectively support high traffic websites and connect to server farms to increase capacity. Additionally, IIS incorporates built-in security features such as IP blocking, options for whitelisting and blacklisting traffic, and support for SSL and TLS encryption. The Windows Performance Counter enables organizations to monitor resource usage, uptime, traffic, errors, and more. To enhance IIS security, several practical measures can be taken. It's advisable to disable directory browsing, ensure SSL TLS is enabled, and activate event tracing logging. Apache is a widely used option for building websites using the HTTP protocol. It is a free open source project that offers commercial grade software. Currently, Apache is the most popular web server, powering millions of websites with its customizable code. The Apache API allows developers to create models that provide various services, such as authentication using an SQL database, content compression, error logging, enabling SSL TLS encryption, proxy IP addresses, and more. While Apache has native security features, additional measures can be taken to ensure a secure environment. Some common tips include adding timeout or keep alive commands to reduce the risk of denial of service attacks. Disabling the execution of server-side includes SSI and Common Gateway Interface (CGI) scripts, and restricting users' access to prevent visibility of server configuration in the directory.